Okay, so here I can write say flip-flop JKFF, okay, or RSFF. Say it is R, and here it is Q. This is symbol for flip-flop. Okay, over here it is CRK, clock, and at the below it is S. S, and here Q bar. Okay, so this is symbol for RSFF, or can say clocked RSFF. Okay, this is symbol for clock RSFF, and I can say this one is 1 bit. This is nothing but 1 bit resistor. Okay, 1 bit resistor is nothing but a single flip-flop. Okay, if we look at the characteristic of flip-flop and this resistor, so both are same, and resistor is nothing but a combination of flip-flop in a specific manner or pattern. Okay, we'll discuss what are the specific patterns, but this is about the resistor. So purpose for a resistor is to store values temporarily. Okay, what is use of this resistor? It can store value temporarily, as well as it would helpful to shift data. Okay, we are not only interested in storing data, we have to use that data in further process. So for that purpose we have to shift our data. So shift purpose. Okay, so whatever the use or application where we store data is known as a buffer resistor. Okay, and the next one is for shifting data, we have left shift, right shift, serial shift, parallel in, parallel out, kind of different shifts. Okay, so this is basic about this processor. Suppose I want a 4-bit resistor, then it would be combination of 4 different flip-flops. Understand? We have 4-bit resistor, help of 4 flip-flops. Okay, so number of bit increases, we need to increase the number of flip-flop. So first question, it is about, this is basics of flip-flop. Now we have to talk about the classification. So in classification we have learned one, it's not about this, Malhar's key of memory classification. Okay, we don't have any key over here, but it is very easy. So first classification type is how does data remain, or data enters and goes out. Okay, so whether it is type of resistor, first retain in resistor. So does this flip-flop temporarily hold your data, stores or shift the data? So based on this we have two types, shift type resistor or buffer type. If it is storing the data, then it is buffer type resistor. Okay, shift or store. The next is how does data enters and taken out. Okay, how data, or data in the sense number of bits, enters and taken out, how does it goes out. So here there are different 4 types. We know it may enter in terms of serial or in parallel. Okay, serial or parallel. So here we have serial and parallel, and data will enter, that is input, and goes out is output. So 2x2 combination. So we will have different 4 type: serial in, serial out, then serial in, parallel out, then parallel in, serial out, and parallel in, parallel out. Understand? So these are the different 4 types of resistor on basis of data enters and goes out. Okay, we'll learn each model. See, this first is our storage or shift register. If we are talking about a 1 bit data, then this is our shift register or storage register. Okay, it is nothing but a resistor. Okay, then third one is classification based on shifting data. How does data shift? Types of shift. So on basis of type of shift, so how many shifting types are available to us is left shift, right shift, then by shift, then circular shift. Understand? So these are the number of shifts available to resistors. And the last and important one is on based of material or the circuit technology. Okay, we can say it is based on material. Okay, so generally or in based on circuit technology. Okay, let I broadly write based on circuit. So based on circuit technology, it has 2 types. It may static or dynamic. Ultimately, we are talking about the material, but here we have to describe in this term, static and dynamic. Okay, so if we are talking about the static resistor, so if we have used this bipolar material, and even unipolar can be also used to create the static type of resistor, but dynamic can made with MOS, or I can say it is using CMOS, PMOS, and MOS kind of unipolar material only. Okay, this static can be made of unipolar as well as bipolar or unipolar. Okay, it static resistor can made of any material, but the dynamic can be made with MOS family. Okay, so as we have discussed in our previous lecture, this has more space. MOS family are more spacious and they consumes less power. They have more capability to work. Okay, while bipolar has more power generation and less capacity to work, and it is bit bulky because of less density. Okay, so this is basics difference, and this all is our classification. First is storage type, whether it is buffer resistor or shift resistor. Okay, second is how does data enters and go out. Third is shift type, left, right, by shift, and circular. How we can move around, whether you can go left side, right side, are you able to turn both the sides. And yes, there is one more term is universal shift. So it is a type of resistor where all moves, circular, by, left shift, all are allowed, is known as a universal shift. Okay, or circulating shift. So the data, last data would be entered to the first resistor. Okay, so this is classification of resistor. Now next question is, and if it is asked for 3 marks, then you can write this in detail, but if it is a 4-mark question, then you should give one example of any of this. Okay, so any examples, say parallel in, parallel out. Suppose you have to just explain how does data enter and go out in a resistor. So PISO PIPO. Okay, so in general you can write like this also. Here it is one resistor, and let I draw all four figure together. So here it is, say serial in, serial out. This is SISO. Then there are parallel in, serial out. Then serial in, parallel out. And last one is parallel in and parallel out. Understand? So you just need to draw this figure, all four, and then explain. So here we can say this one is SISO, SISO. This is N bit input. Okay, and while this one is M bit output. Okay, similar way this one is PISO, parallel in. So in this case we have to write over here, it is LSB, low least significant bit, and this one is MSB, most significant bit. Okay, and here it is M bit output. Okay, so similar way here it is N bit. Over here I'm not going to describe all. So this one particular model is, this particular is SIPO. Okay, and this one is most this is convenient one, but this one PISO is most difficult one in the real sense, because all are entering, but you are dealing or you are sending out only one data. Simultaneously four enters, but you have to deal only one. So it would be a bit complicated. Okay, or we need extra circuit to achieve this model. Okay, and the last one is PIPO, and this is most effective one. If I talk about this, so there are suppose 4-bit resistor. See, if it is I want to send 4 bits, then I must have 4 clock. Use of 4 clock would be there. But in parallel case, if I want to transfer 4 bit, then within 1 clock it would transfer all together, all 4 together on the next end. Okay, so this is types of resistor. How data enters and goes out. Okay, now let us have one example for shift resistor. Serial in, serial out, left shift resistor. Okay, our next type is a store or shift. So in shift we have left, right, bi-shift, circular shift, universal shift. Okay, you can have screenshot of this, or if you have a book then you can just go through it. Class book, if you have made class notes, then you can go through it, and if you have doubt then you can raise your hand. Now next is our shift resistor. So in shift resistor, let us start with right right shift, because it is bit easier. Okay, here we have to say 2-bit. It is 2-bit right shift resistor. Okay, whenever you find question or whenever you start third question, you have to look at the question twice, whether it is asked for resistor or counter. Okay, first thing you have to look at the resistor or counter term, then look whether it is shift resistor or store resistor, how many bit for that resistor. So this is resistor, it is shift resistor, and it has 2-bit. Okay, so in resistor or in counter, the number of bits equals to number of flip-flop. So here we have 2 bits, so it would be 2 flip-flop, or there would be use of 2 flip-flops. Okay. Now there is one clock pulse that is common to all. Okay, once we have to provide the clock pulses, so this clock pulse are common to all. We have to give common clock first. Okay, and say this is kind of age trigger clock, so we have to compulsorily draw age trigger clocks. This is because we haven't used an inverter over there, so it is positive age trigger clocks. Okay, and then it is, see here it is nothing written whether it is SISO, PISO, anything. Okay, so if it is not specified, then we'll like to have SISO only. Okay, because it is more easy or convenient option, that's why. So here we have our output. Say this is our D flip-flop. Say this is D. So we don't need to write anything else. This is D flip-flop and here it is Q. Then here it is again D flip-flop and it is Q. And over here I can write it is Q bar. Okay, so this is nothing but our, yes, we have to carefully describe that this is say serial. First term should be there is serial, then right shift input. Okay, it must you must specify this term likewise. This is shift, this is input and it is right shift input. Okay, and over here we have to write this particular is, what is this? Right shift output. Understand? Here you can write it as clock, CLK clock. Okay, so our figure is over here and you can write here it is also clock, common clock. Okay, so at the first clock, if I draw, it would take a bit more time, but let I draw once I need to draw. See, we have to give name. First you have to draw kind of figure and then after you should start writing name. For this flip-flop, say it is AFF and over here this is BFF. So this particular is QA and here this is QB. Understand? And this is also QA and Q bar A and Q bar B. So here we can write this particular is A and next is B. Okay, and here it is serial in, serial out. So we have 2 bit data, say it is 1 and again we have only 1 data to transfer. Okay, so at the first clock this data would enter. This data would enter over here at first clock. Okay, and then at the next clock it would enter to the B. because it is serial, we need to have 4 clocks. So here first we have at the first clock our 1 bit would transfer to the A. First input will enter into the A flip-flop. Okay. Then at the second clock, it would and the output of this A would be entered into the BFF. Okay. So here first time it is a 0, then next time this one would enter into B as input. Okay. And at that same time this another one would also enter into the 1. Okay, so here it is 1, and here we have to write it is our output. So first we are having nothing, but at the third clock, let I write over here, it is clocks. So first clock we don't have any output at the first clock. At the second clock we don't have not 0, but so it is first clock. Then at the second clock, then third clock, fourth clock. Okay, so at the first clock we don't have any output, second clock we don't have, second clock input will goes into the BFF. At the third clock, okay, at the third clock your output would be at here, and this B will be over here. Okay, there is just a shift of data according to the clock. So at the third clock we will have our data that is 1 over here, and simultaneously output of B, A would be inside the B. And here it is at the fourth clock we would have our output 1 on the another end. Understand? So you can write like this for any of number of bit. It may 4 or 5 or anything. Okay. So this way the data is shifted from one direction to another direction. In the left, this one is right shift, so data is moving towards the right direction. Understand? First input data into the A, then output of A will enter into the B, and B will provide output to the output terminal. Okay, so this is our scenario. So the thing is we have double number of clocks, 2 cross number of bits. Okay, so here we have 2 bits, so we have to 2 cross 2 equals to 4 clocks required. Okay, to transfer 2-bit data we require 4 clocks because it is serial 1. See, in a question there is a nothing written related to types of shift, but they may write like this also. Okay, just have a screenshot of this, then I will modify this figure in some more effective manner. This is our serial in, serial out. Okay, so for SISO I have to write over here for SISO. This is for SISO. Suppose it is parallel, serial in, parallel out. Then I'm modifying this figure as serial in. This is turn input is okay, but we are not happy with this serial right shift output. So I have to write over here this is parallel output, right shift right shift, but parallel. Understand? So in parallel output, here we have another output terminal. Okay, here we have our QA. You can write this is our QA. QA, and this is our QB output. QB output. Okay, so at this time, when we are editing the values, at same time on the next clock only we will have our output. See here, at the third clock we are having output, but on the very next clock it would at the output over here. Okay, and at the second clock it would enter into the B, and at the third clock, rather than going out here, rather than going to the next, it is going to the next as well as it is providing us the output. So on first clock we would have our output. Okay, first clock it would enter into the B, as well as I should write like this, one serial in and parallel out. So in our previous case there are 2 bit for sending to 2-bit output. Okay, at the first clock we don't have any output, but at the second clock we will generate our output of first flip-flop, and the third clock we will have output of our second flip-flop. So if I talk about, this is parallel shift, serial in, parallel out. So in serial in, parallel out, SIPO, we have input equals to how many bits required for input would be same as number of bits. So there would be 2 bit. Here we have 2 bits, so we require 2 clocks for input. 2 bits, so 2 clocks. Okay, number of clocks equals to number of bits in serial. And for output, we require only 1 bit. Okay, output would be shift on the same bit. Okay, so we don't need. So in this case, we require maximum 3 clocks. Okay, so SIPO is more effective compared to SISO, or it provides us the higher speed. Okay, but if I talk about the PIPO, then in PIPO, let I draw again the PIPO, 2-bit PIPO. You can draw this figure also. Okay, there is nothing wrong. If it is not specified anything, then you can write like this also. Here 2 bit are added simultaneously. So of course it has to send data to the next one. It is one thing. Parallel in. So these are connected to each other via input only. Otherwise, they are all having their own data to deal with. Okay, so see, this one is our input. Sorry, clock. This is our input. parallel input, and here it is also have its own input, parallel input, and then it would have its output. Understand? We have our output over here. So at the first clock, okay, whenever there is any clock, we have to provide our input over here. Say it is, here we can write like this. This is if it is jk, okay. If you are doing, if you don't remember, or if you get confused, then go for dff, okay, because we have to invert our input. In jkff we are not providing two inputs, okay, so use dff if you get confused over here. Otherwise, if it is say rff, okay, then here it is q, it is again r and q. So here there should be s, q bar, s, then q bar, then again s and q bar. Okay, I have to draw bar. So if we are going to do or draw like this, then we have to invert our output compulsorily. Invert whatever input you provide over here, it should be converted into the complement. Okay, it would something like this. We have to find invert it. Okay, and similar way we have to draw over here, and there is also our inverter. Okay, because our data is single one, say it is 1 and 1, we have data 1, and over here it is 1 also. But so here we have qa and qb. This is qa and qb. Okay, so how many bits required, how many clocks required to transfer 2 bit in parallel mode? At first clock only, here these are clock. So at the first clock both will have, this is say aff, and this one is bff. So at the first clock only both are having their inputs, okay, and the very next clock both would be turned as output. Okay, no one is dependent on any resistor, all are have their own input and their own output.